Hi folks, this is Karim Raouf from our IT Visualizer channel. We will continue our lab, the Matrix lab. This is the video number 2. We have stopped the last time in video 1 at minute 34:46. In this minute we have been restarting our virtual machine after installing the VMware tools so we can able to communicate and uh, transfer and copy and paste between my host and my guest, which is the virtual machine. So the VMware tools, as we have said before, it helps us to efficiently communicate with the virtual machine, sharing files, copying and pasting from the host to the guest, uh, installing drivers. The VMware tools install drivers that enhance the performance of the virtual machine and a lot of things actually. So after restarting the machine, we need to log in back, you will see, and I need to add a second network or virtual network adapter because this will be our domain controller and we need to have two network cards to make teaming between them, so we have something like network load balance between the two network adapters after teaming them, of course. So let's see first how this teaming will be done and uh, how this teaming is done in a physical environment and in a virtual environment. So I here assume in my lab that this is a physical on-premise environment. So in a physical environment, you have network adapter cards, you can team them, but in a virtual environment, the teaming will be done in a different way and method. So let's first see how we can add the network adapter and then team them. So first we are making a restart, and remember there is an issue with this Windows Server 2025 version. It's still not compatible with the VMware Workstation Pro. So sometimes you're not able to restart or shut down. So you need to have a little bit of a workaround to do that. So to do that, you can restart the virtual machine from this button and shut down the virtual machine from this button, or you can simply power off the virtual machine completely and then open it back. So we can see here I am having a hang issue, so I make a restart from this icon. Okay, so now I have already installed the VM Workstation Pro or VM Workstation Pro tools and then or VMware tools. So now we have our tools installed. We will go inside and then I should uh, shut down the machine completely and begin adding the second network adapter. Okay, second network virtual adapter. Okay, so simply we can see that there is a lot of similarities between the Windows Server 2025 Vnext edition and the Windows 11. Even the background, you can see the background is the same, the icons are the same. There is the Windows Terminal option, which was a very long-awaited feature that all of us demanded, or most of the technical experts asked it to be added to the Windows Server because it was only on the Windows 10 and 11 operating system or the client operating system. Windows Terminal is a very good feature. You can open a lot of uh, command prompts. For example, the Windows command prompt, the PowerShell 5 command prompt, the PowerShell 7 command prompt, the Azure command prompt. All of this can be opened in one window or from the Windows terminal. So it was a long-awaited feature to be added to the Windows Server. It was only exclusive, or it was only working from the Windows client operating system like the Windows 10 or Windows 11. So now we have to power off the virtual machine, and this is, by the way, option. If you see this message, I have already an option activated. If I power off the machine, I need to be asked if I need only to power it off or to take a snapshot. This is a very good option, just to remind you to regularly take snapshots to make sure that your workstation always you have a backup, always you have a restore system, restore point, so you can return back in time if anything happened to this virtual machine. So now when we open, we will edit the virtual machine setting. And then we need to add a network adapter card. Remember that we have our network as VMnet 8. Remember, here we will go and add it to VMnet 8, okay? And then we have two network adapters on the same network. So, as we said before, the network teaming between the two network cards will make network load balance. So, the two combined will share or divide the data uh, through divide the data sending and receiving. So this will divide the balance or the load balance or the network load balance on these two cards, and they will have combined speed. So for example, if you have one network card 10 gigabytes, you will have two network cards with 20 gigabyte of data sending and receiving. So this you will have the double speed, we will have network load balance. And if one of them fail, okay, the connection will not fail automatically. The second network card will go in and save the connection from disruption or from disconnecting. Okay, so this is very good option. uh, it's mostly done on all of our servers, but this is done on the physical on-premise. You have the server, you have mostly in most of the servers 8 network cards or more, so you can do the network teaming through the operating system, Windows Server operating system. And I think you can do it from the BIOS or the firmware of the servers. You can do it through both ways, but what or how this can be done through vSphere environment or virtual environment, how this can be done, the teaming will be done through the virtualization or hypervisor environment, or from which system. So this was my idea. I cannot imagine. I have worked in a vSphere environment, but really I didn't make teaming before on a virtual environment. So this was my challenge, or this was my question to ChatGPT. I told him I have a physical server, I have two network cards, and I have made network teaming by the operating system, which is Windows Server 2022. What if I have a virtual server? How the same concept can be applied? So here he began explaining and saying to me what is or how this can be done. So let's first, I need to go and tell it to read it loudly so you can hear it.
Network teaming, also known as NIC, Network Interface Card Teaming,
Let's hear.
is a way to provide redundancy and in-network throughput by grouping multiple network interfaces. This concept can be applied both in physical servers, as you have done with your Windows Server 2022, and in virtual servers, although the methods and technologies involved might differ slightly. Applying network teaming in a virtual environment. 1. Virtual NICs in VMs. In a virtualized environment, virtual machines, VMs, use virtual network adapters provided by the virtualization platform, such as VMware ESXi, Microsoft Hyper-V, etc. These virtual network adapters emulate real network cards and can be configured similarly to physical NICs. 2. Teaming software or hypervisor features. Hypervisor level teaming. Most hypervisors have their own native features for network redundancy and aggregation, similar to NIC teaming on physical hosts. For instance, VMware vSphere provides network features like link aggregation groups, LAGs, using vSphere distributed switches. Hyper-V offers NIC teaming, where you can team the virtual NICs within the VM or the physical NICs on the host. Guest operating system teaming. Just as you set up NIC teaming in Windows Server 2022 on a physical server, you can configure NIC teaming within the guest operating system of a VM. This involves using the same OS-level tools and configurations you would use on a physical server. 3. Configuration considerations. Matching teaming policies. Ensure that the teaming policies configured in the guest OS align with the network policies on the physical switches and the virtual switch settings in the hypervisor. Misalignment can lead to traffic flow issues and loss of redundancy benefits. Load balancing and failover. Choose appropriate load balancing and failover modes based on your network traffic patterns and availability requirements. Common options include load balancing based on the source destination MAC address, IP, or port numbers. 4. Integration with physical network. When setting up NIC teaming in a virtual environment, it's crucial to ensure that the physical network infrastructure, like physical switches and routers, supports your configuration. This might include settings for LACP, Link Aggregation Control Protocol, or static link aggregation on the physical switches to match the aggregation method used by your virtual switches. Number 5, monitoring and management. Regardless of whether NAC teaming is configured on the hypervisor or inside the VM, proper monitoring tools should be implemented to track the performance and status of network links. This helps in proactive management and troubleshooting of network issues. By using these methods, you can achieve similar redundancy and performance improvements in a virtual server environment as you would in a physical server setup. The key difference lies in managing and configuring these settings through virtualization software layers rather than just the operating system.
So here we can see that the difference between network teaming on a physical environment or in a physical environment or in a virtual environment, that the teaming is done through the hypervisor software. So the vSphere had a way that you can make network teaming through it. You just give him the network cards and then insert it in a virtual switch, and then make link aggregation on this physical this virtual switch. So in very short terms, the network teaming is done through through the hypervisor software. If it is vSphere or it is Proximox or Hyper-V, okay, all of this done through the software of the virtual or the virtualization software. Okay, so this is very simple thing. So we will not make network teaming through the operating system, not operating system, by the way. So for example, if you have Windows Server, you will do the teaming through the Windows Server, or through uh, as I said before, through the BIOS or through the firmware. But what if we have vSphere, for example, you have EXI host installed, you don't have any Windows operating system, you have EXI host installed on operating on a server, and then you have vSphere that connect or that monitors all of the EXI host. So then the network teaming will be done through the vSphere. Okay, so this is the answer of ChatGPT 4. What about Claude? If you go to Claude and ask the same question, say in a virtual environment, the concept of network teaming or NEC teaming can be applied in a similar way in a physical server. However, instead of having physical network cards, virtual servers use virtual network adapters. Okay, this is okay. We have virtual network adapters, but here we are talking about the teaming. In a virtual environment such as VMware, Hyper-V, or KVM, the process of configuring network teaming on a virtual machine typically involves the following: virtual switches. Okay, you have a virtual in the hypervisor management interface, vSphere client for VMware, Hyper-V manager for Microsoft, or virtual machine manager for KVM. You need to create one or more virtual switches. These virtual switches act as a software-based network switch similar to the physical switch. Okay, and then if we go further, uplink assignment, add or assign one or more physical network adapters from the host machine to the virtual switches and uplinks. This allows the virtual switch to communicate with the physical network. So again, uplink assignment, you assign a couple of physical network adapters to this virtual switch, and then you make something, as we said before, link aggregation. Here he say virtual network adapters, create and configure multiple virtual network adapters for the virtual machine. This is okay. You can add a couple of virtual network adapters on the virtual machine and team them, but actually this teaming is not real because they are all pointing to one or are pointing to the same network adapter. Anyway, the real teaming is done on the switch or the virtual switch. Here, let's see, here is saying that we uplink assignment here. You add two network adapter cards on the virtual switch, and then you make a link aggregation between them. Link aggregation, it's like combining two ports to act as one port. Okay, so and making some failover mechanism, so the two ports act as one port. Okay, so you have double speed, and you have a failover mechanism. If one of the ports fail, then it will be redirected to the other port. Okay, so he is saying virtual network adapters, this is good. Then teaming configuration. In the VM setting or configuration, you can enable and configure network teaming for the virtual network adapter, similar to what you have did on the physical server, Windows Server 22. These specific steps may vary depending on the hypervisor and teaming technology being used. NIC teaming in VMware, NIC teaming in Hyper-V or Linux. Okay, he didn't give us the way to do that, but we will ask another question: how we can do network teaming, for example, in Hyper-V environment. Let's see, or in VMware. Load balancing and failover. Configure desired load balancing and failover setting for the teamed virtual network adapters, just as you do on the physical. Okay, this will not be done through the virtual network adapters. This will be done. Okay, this can be done, sorry, to the virtual network adapters. You can make teaming and tell him the failover and loading balancing, but as I said before, the real work is on the virtual switch. Okay, and by the way, the virtual network adapters, you are only adding it just to separate networks from each other, because I said before, uh, the virtual network adapters, uh, if you add even 10 or more, they will act as one, or they are to the system, they are pointing to one or two network adapters. So they are only files, they are not real network adapters. So it doesn't matter if you add one, two, or three, or four and make teaming. This is not a real network adapter, this is a virtual network adapter. So what seems to be logic, that all of our teaming will be done on the virtual switch. We will add the physical network adapters and then make the link aggregation. Anyway, so we'll go is saying load balancer, then virtual switch configuration. Depending on the hypervisor, you may need to configure the virtual switch to support the teamed virtual network adapters and the desired teaming policies. Anyway, we need to see an example how this can be done in the vSphere, for example, and the Hyper-V. So this is only theoretical speaking. How we can do that? Give us the steps. The key advantage of network teaming in a virtual environment is it provides redundancy and load balancing and failover capabilities for the virtual machine network connectivity, even though the underlying physical network adapters on the host are shared among multiple virtual machines. So let's first close this so we don't get interrupted. Let's go and ask ChatGPT again to give us an example uh, for hypervisor leveling teaming. So let's see here what you have to say. So I need to give me an example on hypervisor level teaming. Let's see how the hypervisors can make network teaming, for example, for the vSphere. So let's see.
Sure, let's consider an example of hypervisor-level network teaming using VMware vSphere, which is one of the most common platforms for virtualization. VMware allows for advanced network configurations like link aggregation, which can increase bandwidth and provide redundancy through the use of vSphere distributed switches, VDS. Example scenario, configuring link aggregation in VMware vSphere. Increase the network bandwidth and provide redundancy between your VMware ESXi hosts and the network switch. Requirements: VMware ESXi hosts, a vSphere distributed switch, physical network switches that support LACP, link aggregation control protocol, or static link aggregation. Steps to configure network teaming on vSphere. 1. Prepare your physical switch. Configure the physical switch ports that connect to the ESXi hosts to be part of an LACP group if using LACP, or a static ether channel for static link aggregation. This setup needs to be done on the physical switch side to ensure it can aggregate links that the ESXi hosts connect to. Number 2. Create a vSphere distributed switch. Log into the vSphere web client. Navigate to the networking section and create a new vSphere distributed switch. Specify the version and the number of uplinks. For link aggregation, you generally need more than one uplink. 3. Add hosts to the vSphere distributed switch. Add your ESXi hosts to the vSphere distributed switch. This process involves migrating the host's network adapters to the new switch. 4. Create a link aggregation group LAC. In the vSphere distributed switch settings, create a new lag. Choose whether to use LACP or a static link aggregation based on your earlier configuration on the physical switch. Assign physical NICs from your hosts to the lag. Each NIC should be connected to a port on the physical switch that's part of the configured aggregation. 5. Configure load balancing and teaming policy. Edit the teaming and failover settings of your port groups on the vSphere distributed switch. Set the load balancing policy to route based on IP hash, which is typically recommended for link aggregation setups. Ensure that the network failure detection is set to link status only, and set notify switches and failback according to your redundancy preferences. 6. Test and validate. Once configuration is complete, test the network performance and redundancy by simulating failures, like disconnecting a network cable, to ensure the network continues to function and that the bandwidth increases as expected. Use monitoring tools available in vSphere to observe the traffic distribution and ensure that it is balanced across the aggregated links. This setup will allow the ESXi hosts to utilize combined bandwidth of the linked network interfaces, increasing throughput and providing redundancy in case one of the links fails. It's important to regularly monitor the setup and make adjustments as needed based on network load and performance metrics.
So we can see here it is basically saying us the steps how we can do this in a vSphere environment, very detailed steps. Okay, how this be done? First, from the physical switch you need to make link aggregation, and then through the physical switch, so the virtual switch, you need to make link aggregation, adding the physical network cards to the virtual switch and making the link aggregation. As you can see here, I think, or I told him to explain it in simple terms. So because I think it was a little bit complex. So let's see, when I told him to make it more simple, what does it say? Actually, it amazed me that it make it more simpler, and I began to understand. So let's see.
Certainly. Let's simplify the concept of hypervisor-level network teaming, often used in virtual environments like VMware vSphere. What is network teaming? Network teaming involves combining multiple network connections into a single group. This setup improves the overall network speed and reliability. If one network connection fails, the other connections in the team can take over, ensuring that the system remains online without losing connection. How does it work in a virtual environment? In a virtual environment, such as when you're using VMware, a type of software that creates and manages virtual machines, the concept is similar but implemented virtually. 1. Virtual switch. This is like a digital version of a physical network switch. It connects virtual machines to each other and to the outside network. 2. Link aggregation. This is a method used within the virtual switch to combine multiple network links into a single link. This aggregation increases the total bandwidth available to the virtual machines and provides redundancy in case one of the links fails. Example: setting it up in VMware. Imagine you have several virtual computers, virtual machines, running on a VMware server. You want to make sure they have a fast and reliable network connection. 1. Set up in VMware. You create a virtual switch in VMware that all your virtual machines will connect to. You then configure link aggregation on this virtual switch. This means you're telling the virtual switch to treat multiple network connections as one. 2. Physical and virtual settings. On the physical side, you ensure the real-world network switches, the hardware in your data center, are set up to understand and support this aggregation. On the virtual side, you configure VMware to use this setup so that it can distribute network traffic efficiently across the aggregated links. 3. Benefits. Your virtual machines now have access to more network bandwidth, which can help when lots of data needs to be moved around. If one network link fails, the system will continue to operate using the other available links, thereby enhancing reliability. This approach is beneficial in environments where maintaining network uptime and maximizing performance are crucial. It's like having multiple roads leading to the same destination. If one is blocked, the others can handle the traffic.
So you can see it is very simple. You do uh, how to do or network teaming through the virtual environment, and uh, to set up your physical environment to support this virtual configuration. You need to do both on both sides, from the physical side and the virtual side. And you can see here the explanation is very simple, and actually no more talking need to be done, because it's already very easy to understand. If we go to Claude 3 and see, to give us an example, here I'm telling you an example here. Recently, hypervisor leveling or level teaming, known as virtual switch teaming or NIC teaming at the hypervisor level, allows you to combine multiple physical network adapters on the host machine to a single logical team. This team is then used as an uplink for one or more virtual switches on the hypervisor. Let's see here. He's saying that you combine physical adapters on the host machine into a single, then this team. I think this is not correct. Here he's saying open the vSphere, navigate to virtual switches, and then right click edit setting in the virtual sector, select NIC teaming, click add network ports, button to add physical NICs. Okay, so he's saying the same, but okay, anyway, so here the teaming will not be done through the operating system, or here not through the XI or the XI operating system. Okay, it will be done through the hypervisor. Okay, he's saying the same. You can add physical NICs to the virtual switch and then to make teaming and then configure teaming policy failover according to your requirement. With here, you can choose a route based on IP hash, the same that was set by ChatGPT-4. So here, uh, okay, this is correct. Allows to combine multiple physical machines, physical network adapters on the host into a single logical tail. Okay, this will be done through the hypervisor. Okay, so we can see here is saying the steps, okay, to save so and so. Now any virtual machine connected to this virtual switch will benefit from the teamed uplinks, providing redundancy, load balancing, and failover capabilities. For example, here we have physical team Vnext 0, Vnext 1, teaming policy route based on IP hash, failover. Okay, here we have two kinds of failover. One to be active and the other standby. So if this is down, this will go uh, from standby to active, or both active, so you have load balance. Okay, so here he is making the failover one active and one standby, but here we are only benefiting from one network card. But the best for me is to have both active, so we can have network load balance and double speed. Okay, in this example, the advisor will use both VMNIC 0 and VMNIC 1 for load balancing outgoing traffic based on IP hash. If VMware NIC 0 fails, then VMware will take over and handle all of the traffic. Okay, so he's saying that uh, hypervisor level teaming is advantageous because it centralizes the teaming configuration at the hypervisor level, making it easier to manage and apply the same setting to multiple virtual machines. It allows for better utilization of the available physical NICs on the host. Note that the specific steps and options may vary depending on the hypervisor you are using. Okay, Hyper-V. So this is different on the Hyper-V, for instance. Okay, and KVM. But in general, the concepts remain the same. Combining physical NICs into a team at the hypervisor level and using them or that team as an uplink for the virtual switches. So here I'm telling him, can I make both failover order from VMNIC 0 active, so I need both to be active instead of standby? He's saying yes, you can absolutely make both active in a policy called referred to as active or all active teaming policy. In this example you have provided earlier, the failover order was to set VMNIC 0 active, VMNIC 1 standby, which is known as active passive configuration. In this mode, only one NIC, which is VMNIC 0, is actively used for transmitting and receiving data, while the other VMNIC 1 remains in standby mode, ready to take over if the active NIC fails. Okay, so you can do that. You can go and change the policy or the failover order, okay, to be both active. Okay, so this is very simple. Okay, he's saying he connects or he remains. Let's read the rest. With this active configuration, both VMNIC 0 and VMNIC 1 will actively participate in transmitting and receiving data, effectively utilizing the available bandwidths from both NICs. The load balance policy in this case route based on IP hash will determine how the traffic is distributed across the active NICs. The advantage of an active configuration that maximize the available bandwidth, so you give you better speed, transmission and receiving speed, and to have load balance provides better throughput compared to an active passive configuration where only one NIC is actively used at a time. Okay, However, it's important to note that an active-active configuration, if one of the NIC fails, the remaining active will handle all of the traffic, potentially causing a temporary decrease in performance until the NIC is recovered or replaced. Okay, this is normal, but we don't need the connection to be. I need to utilize both of them to have total or more bandwidth speed, okay, and or transmission speed, and to have network load balance. So this is normal. To configure the active-active failover, simply follow the steps you mentioned earlier, but when selecting the failover order, choose the active option for both VMNext 0 and VMNext 1. Remember the specific options, okay, depends upon the hypervisor, if it's VMware XI, Hyper-V, so on so. So, very, very good explanation that completes what the ChatGPT 4 have said. Okay, so let's see here how to set up link aggregation on a physical switch, for example, like Cisco. Let's see how we can do something like that on a Cisco switch. Okay, let's see uh, the things that you can see here, that here is the steps.
Setting up link aggregation on a physical Cisco switch involves a few steps. Link aggregation, often referred to by Cisco as Ether channel, allows you to combine several physical network links into a single logical link, enhancing bandwidth and providing redundancy. Here's how to set it up. Requirements: Cisco switch that supports Ether channel. Network cables connecting the switch to other devices like servers or other switches on multiple ports. Example setup for LACP, Link Aggregation Control Protocol. LACP is one of the most common protocols used for link aggregation because it provides a dynamic and automated configuration, helping devices to negotiate an automatic bundling of links. Step 1. Plan your configuration. Identify the ports on your Cisco switch that you want to aggregate. For example, let's say you want to aggregate ports Gigabit Ethernet 1N1 and Gigabit Ethernet 1N2. Step 2. Configure the physical switch 1. Log into the switch, access your Cisco switch via console cable, SSH, or Telnet. 2. Enter configuration mode, bash enable configure terminal. 3. Configure the ports, assign the physical interfaces to a channel group. This action will automatically create a port channel, logical interface if it does not already exist. Use the same channel group number for all interfaces you want to aggregate. Bash interface range Gigabit Ethernet 10/1 Die2 channel group 1 mode active no shutdown. Channel group 1 mode active. This command sets the ports to actively use LACP. No shutdown. This command ensures the interfaces are enabled. 4. Configure the port channel interface. You need to configure the logical interface created by the Ether channel. This interface represents all the grouped ports. Bash interface port channel 1 description, link aggregation to server switch port mode trunk. Optional based on your network design. Switch port trunk allowed VLAN add 10 to 20. Optional VLAN settings, no shutdown. Description helps in identifying the purpose of the link aggregation. Switch port mode trunk sets the Ether channel as a trunk if needed. Switch port trunk allowed VLAN specifies which VLANs are allowed over the trunk if applicable. Step 3. Verify configuration. After configuring, it's important to verify that the Ether channel is set up correctly and all ports are active within the group. Bash show Ether channel summary. This command provides a summary of the port channel status and shows if the interfaces are bundled properly. Step 4. Save configuration. Don't forget to save your configuration to ensure that it persists after a reboot. Bash write memory. Considerations. Consistency. Ensure all ports in the Ether channel have the same settings, speed, duplex, and switch port settings to avoid issues. Cross-device support. If connecting to devices other than Cisco, ensure that they also support LACP and are configured accordingly. Redundancy. Properly plan the physical connectivity to maximize redundancy and prevent single points of failure. By following these steps, you can successfully configure link aggregation on a Cisco switch, enhancing your network's bandwidth and redundancy capabilities.
So you can see this is very, very simple and straightforward steps to how to do link aggregation through a physical switch like Cisco. If you go to Claude and see the same, or ask him the same question, he will give us the same but in different order. So for example, to configure link aggregation on Ethernet channel on a Cisco switch, you need to do the following. Configure port channel interface, create a logical port channel interface on the switch using interface port channel command, assign a port number, configure any necessary port channel setting as load balancing algorithm or mode. Okay, and then he give us the command. Okay, configure interface port 1, switch port mode trunk, load balance. Here you choose the type of load balance. Configure the physical interfaces. Identify the physical interfaces you want to bundle into the Ethernet channel. Configure each physical interface to be a part of a port channel using the channel group. The same. You can see they have the same on ChatGPT 4 saying the same. Specify the port channel you have created earlier. But I think in ChatGPT he made it in less steps. Interface, so and so, channel group 1 mode. This makes it using link aggregation. Okay, and interface Ethernet 2 or Gigabyte Ethernet 2 also using link aggregation. So both are on the same channel group and both are having link aggregation protocol enabled on them. Verify the Ethernet channel. Show Ethernet summary command to verify the Ethernet channel configuration and status. Ensure the physical interfaces are bundled and the Ethernet channel is operational. Okay, so now we can see here the command, and you can see here there is in Claude a more simulated result. We can't see that in ChatGPT. Here is giving us what will appear in front of you. Okay, a simulate of what will happen. Okay, you can see here the what the result will, how it will be displayed. Okay, so after that, configure the port channel on the connected devices. When the device is connected to the switch, another switch, router, or server, configure the responding port channel interface for Ethernet. If you are connected to another switch, make sure you have link aggregation also enabled on the other switch. Ensure the configuration on both sides matches port channel number, load balancing algorithm, and so you need to make sure that you have the other port or the other ports connected to another switch have the same configuration. I think it is better to have the same model so you can make the same configuration. Note that the specific commands and options may vary slightly depending on the Cisco iOS or NXOS version running on the switch. Always refer to the official Cisco documentation or use the built-in help for the most up-to-date and accurate command syntax. Okay, additionally, it is essential to ensure the physical interfaces bundled to the Ethernet channel are connected to the same device or switch on the other end. What I was saying, okay? Connecting the physical interface to different devices or switches can cause issues and prevent the Ethernet channel from forming correctly. So you need to have all of them or all of the switches the same model so we can make the same configuration. Okay, because some switches have different configuration. Maybe some switches does not support link aggregation, or they have a different way of dealing with link aggregation, or they have link aggregation only working with the same model of switches. Okay, so let's see. I tell him to explain in simple terms. Let's us explain link aggregation or Ethernet channel configuration on a Cisco physical switch in simple terms. Create a logical bundle. You need to create a logical bundle or a group on the switch, which will be the container for the physical ports you want to combine. Okay, so you have a logical group. Okay, two group physical ports in it. Okay, the logical bundle is called the port channel or Ethernet channel on Cisco switches. Assign physical ports to the bundle. Once you have created the logical bundle, you need to assign the physical Ethernet ports that you want to combine into this bundle. You essentially tell each physical port to become a member of the bundle. Okay, this is very, very simple. Configure the bundle setting. You can configure various settings for the logical bundle, such as load balancing method, how traffic is distributed across the bundle ports, and the mode, how the bundle behaves with the connected devices. Verify the bundle. After configuring the bundle and assigning ports to it, you can check the status of the bundle to ensure that it is operational and that the physical ports are properly bundled together. Configure the connected devices. On the device connected to the switch, another switch or router or server need to configure a similar bundle or Ethernet channel, ensuring that the setting match the configuration on the Cisco switch. So it is another switch, you need to have the same configuration on the other switch or router, okay, or server. Okay, but in the server I think we will not make any we'll make teaming, okay, on the server, or it's different. I think here you need to focus on the switch configuration and the router configuration. For example, let's say you have two physical ports, Ethernet 0 1 and a gigabyte the Ethernet 01 and gigabyte Ethernet 02 on the Cisco switch. You need to combine them to a single logical bundle. For higher bandwidth and redundancy, you would create a port channel, let's say port channel 1 on the switch. Then you would assign two physical ports, these two ports, to this port channel 1. You configure the load balancing method for the bundle, such as load balancing traffic based on the source and destination IP address. After configuration, you would verify that the bundle is operational and that both physical ports are bundled correctly. Finally, on the device connected to the switch, you would configure a similar bundle or Ethernet channel to match the switch configuration. Bundling multiple physical ports into a single logical bundle, you can get higher bandwidth as the traffic is distributed across the bundle ports, and redundancy. If one of the physical ports fail, traffic can still flow through the remaining bundle ports. The specific commands and options may vary based on the Cisco switch model and iOS version, but generally the concept remains the same. Create a logical bundle, assign physical ports to it, configure setting, verify the bundle, and configure the connected devices accordingly. Okay, so very simple. So we can see here that uh, very simple explanation. Another question I need to ask ChatGPT: do I need to insert two virtual network adapters on a virtual machine and team them using the guest OS operating system after making link aggregation on the virtual switch? So I have already made link aggregation on the virtual switch and link aggregation before on the physical switch. Why do I need to insert two network adapter uh, uh, virtual cards on a virtual machine? I think they will act as one. Okay, so all of these are virtual network adapters. Why do I need to have two network adapters or virtual network adapters on a VM? So it is logical that you can make link aggregation on the physical machine. This is the logic. So we can make a load balance and the same on the virtual switch. But why do I need to do that on the virtual machine? Why do I need to add two virtual network adapters on a virtual machine? Okay, so why do I need that? Why do I need to insert two virtual adapters? Okay, they are simply not there. This is a virtual network adapter, so teaming is nonsense on the virtual in the virtual VM. Okay, so because I don't have physical adapters on the virtual machine and making or linking them or teaming them, this is done on the virtual switch in the vSphere option. This is not done through the virtual VM. So let's say here, why do we need that? Yes, you are correct in this approach. Let's see why we need to add two virtual network adapters in a VM, even though the teaming is done on the virtual switch. Let's see how, let's see why is this done and see ChatGPT for saying the reason.
Yes, you're correct in your approach. And here's a clear breakdown of the process and reasoning behind each step when setting up network teaming involving both virtual and physical environments. Step 1. Physical switch link aggregation. You first set up link aggregation, like LACP, on your physical Cisco switches. This combines several physical ports into a single logical link for higher throughput and redundancy. Step 2. Virtual switch configuration. Next, you configure link aggregation on the virtual switch, like vSphere distributed switch, within your hypervisor, e.g. VMware ESXi. This virtual switch configuration should ideally align with the physical switch setup to maximize the effectiveness of link aggregation from the physical layer all the way up to the virtual layer. Step 3. Adding virtual network adapters to VM. To utilize the aggregated network setup fully within your virtual machines, you would 1. Add multiple virtual network adapters. Insert 2 or more, depending on your requirements, virtual network adapters to your virtual machine. These adapters will connect to the virtual switch that's already configured for link aggregation. 2. Configure NIC teaming in the guest OS. Inside the guest operating system, such as Windows Server or Linux running on your VM, you then configure NIC teaming. This configuration allows the operating system to manage how traffic is balanced and how redundancy is handled between the virtual network adapters. Why each step matters. Physical layer. The physical link aggregation ensures that there's a high bandwidth and fault tolerance at the hardware level. If one physical connection fails, others can take over without affecting the connectivity seen by the servers and, subsequently, the VMs. Virtual layer. The virtual switch link aggregation ensures that traffic from VMs can be balanced across the physical links, maximizing the use of the available bandwidth. Guest OS level. By configuring NIC teaming within the VM, the guest operating system can efficiently manage network traffic across its virtual adapters, further enhancing redundancy and load balancing. This step is particularly useful in environments where the VM needs to handle significant network load or where network failure tolerance is critical. Conclusion. Each level of configuration, physical, virtual, and within the guest OS, plays a crucial role in ensuring that the network is robust, resilient, and can handle the required traffic load efficiently. Thus, the setup you've described is appropriate and advisable if you aim to maximize both network performance and redundancy across your infrastructure.
So one of the things, or one of the reasons why you need to add two virtual network adapters in a virtual machine, and teaming them, even though this is not a real teaming and the teaming is done on the virtual switch, if you need to have two different networks. If you, for example, having two network cards on a virtual machine and you need to connect two different virtual networks on these two virtual network adapters. Okay, so you have, for example, 192.168.0 or point 0.1 and 10.0.0.1. So you need to connect both on, or to combine both, or to have both on a server. So maybe you can add two network adapters, but this was the answer, and I think it is clearly stated uh, why we need to do that. I think, let me see if uh, I go there. uh, Okay, let's do something here. I need to go and ask Copilot. Okay, this is another AI tool. Let's see if it can give us another answer. By the way, Copilot or H Copilot and ChatGPT 4 are working on the same engine. Okay, so let's see what he will give us. Okay, anyway, so we need to make virtual network teaming, okay, on the VM side. So here again, I asked Gemini about uh, the same question. I have physical server with two network cards, and I have made network teaming by the operating system, which is Windows Server. What if I have a virtual server? Okay, so he said that on a Hyper-V, NIC teaming is done at the Hyper-V host level, which not within the VM virtual machine. You group physical NICs on the Hyper-V host into a team, then you can leverage. So here, because the Hyper-V is installed on the Windows operating system, you need to make the teaming on the Windows operating system, then make the Hyper-V manager use this team. So this is how it is done on the Hyper-V. Maybe it's different on vSphere. It's not done like that. Okay, the teaming is done through the virtual switch. So you need to have a virtual switch and then insert the physical cards in the virtual switch and then make the link aggregation or teaming as it's supposed to be. But on the Hyper-V, the teaming is done through the Windows operating system. Okay, and then you can insert in the Hyper-V. Okay, so here, I try to confirm this answer, because sometimes Gemini gives an incorrect answer. So I asked ChatGPT to verify this is a correct answer. So here, if we go there and tell him to verify the answer, this statement. Yes, the statement you provided. Let's see here the statement that I have give him. Let's see how he responded to that.
Yes, the statement you provided is mostly correct and accurately describes the typical approach to NIC teaming in a Hyper-V environment. Here's a breakdown of the statement with some additional context. 1. NIC teaming at the Hyper-V host level. NIC teaming is generally configured at the Hyper-V host level rather than within the individual virtual machines. This approach allows all VMs hosted on the Hyper-V server to benefit from the increased reliability and network throughput without needing individual configuration within each VM. 2. Grouping physical NICs into a team. On the Hyper-V host, multiple physical network interface cards, NICs, are grouped into a team. This grouping is managed through the Windows Server operating system running Hyper-V. The OS uses a feature known as NIC teaming, or load balancing and failover, LBFO, which allows multiple NICs to be seen as a single logical network interface. 3. VMs leveraging the NIC-seek team. Once the NIC team is established on the Hyper-V host, any virtual machine on the host can use this teamed interface for network connections. The VMs are not aware of the underlying NIC-seeks. They simply communicate with the virtual switch, which manages the distribution of network traffic across the physical NICs in the team. The teamed NIC setup helps in providing redundancy. If one physical NIC fails, the other NICs in the team can continue to handle network traffic, thus maintaining network connectivity. Additionally, NIC teaming can increase network throughput by combining the bandwidth of multiple physical NICs, although the actual throughput gain can depend on the teaming mode and load balancing configuration. However, it's worth noting that while NIC teaming is typically done at the host level for simplicity and broader applicability, it is also technically possible to set up NIC teaming within a VM, particularly if the VM runs an OS that supports NIC teaming, like Windows Server. This inside VM teaming can be used for specific use cases where you want fine-grained control over network traffic handling within the VM itself. This scenario is less common and usually not necessary unless there are specific requirements that host-level teaming does not meet.
So we can see here that he is saying the last couple of lines saying that inserting virtual network adapters on a VM and teaming them is not necessary, okay, and you will not benefit from it because the real one is done on the host level, okay. So this is one of the things that I was telling, okay. So he's saying that you can make network teaming on the guest operating system, but this will not be the case because the real thing or the physical thing doesn't have teaming, or didn't make teaming on the physical side, okay. So if you go to Gemini again, I ask him to give me an example how this is done, how we can make network teaming through the Hyper-V. Here gives us an example. He is saying that you can do that through, he said that open the Hyper-V manager, then locate the Hyper-V host, and then access NIC teaming. So he is saying that you can make network teaming through the Hyper-V manager, which is incorrect because I know that the network teaming is done through the Windows Server operating system, not the Hyper-V manager. So this was a mistake. So here I need to point or to make a note. Make sure that you always verify the answer of Gemini because there is a lot of inaccurate info, okay, because this is not correct, okay. When I ask ChatGPT about or to verify that this is done or the network teaming is done through the Hyper-V manager, it said no, it's not correct, and I confirmed that this is incorrect, okay. He's saying here, let's see again. I will give him this answer and tell him to verify it. But before that, do I need to link aggregation on Hyper-V virtual switch? Okay, let's see. So do I need to have link aggregation on the Hyper-V virtual switch? So we make it on the physical. Do I need to do that? So here he give me the answer. Let's go and ask him why do I need link aggregation on the Hyper-V virtual switch? So if I'm using the Hyper-V as my hypervisor, do I need that? So let's see. Here is telling us how we can do link aggregation, but not through the
In a
Hyper-V.
Hyper-V environment, whether you need link aggregation on the Hyper-V virtual switch depends on your specific network requirements and goals. Link aggregation on a virtual switch can enhance both the bandwidth available to virtual machines and the network resilience, similar to how link aggregation works on physical switches. However, it might not always be necessary. Here are some considerations to help you decide when you might need link aggregation on a Hyper-V virtual switch. 1. Increased network throughput. If your virtual machines generate or receive a lot of network traffic, link aggregation can combine the bandwidth of multiple physical network interfaces. This setup can help prevent network bottlenecks that might occur if a single NIC's bandwidth is insufficient. 2. Network redundancy. Link aggregation can provide network fault tolerance. If one of the physical network connections fails, the system can continue to operate using the remaining connections. This is crucial for maintaining uptime and service availability, especially in production environments. 3. Load balancing. Link aggregation can distribute traffic across multiple network links, which can help optimize the network load and improve overall performance. How to set up link aggregation on a Hyper-V virtual switch? If you decide that link aggregation is necessary, here's how you can set it up in a Hyper-V environment. 1. Create a NIC team on the Hyper-V host. Use Windows Server's NIC teaming feature to aggregate physical network adapters at the host level. This is done in the Network and Sharing Center or via PowerShell. Example PowerShell command to create a NIC team. PowerShell new NetLFO team, name team 1, team members NIC1, NESI2, teaming mode LACP. 2. Configure the Hyper-V virtual switch. Once the NESI team is created, you can use this team as an uplink for your Hyper-V virtual switch. Create a new virtual switch via the Hyper-V manager and select the NIC team as the external network adapter for this switch. 3. Connect virtual machines to the virtual switch. Ensure that your VMs are connected to the newly created virtual switch to take advantage of the aggregated link. Considerations. Compatibility. Ensure that your physical network infrastructure, like switches and routers, supports the same link aggregation protocol, e.g. LACP, that you intend to use in your setup. Configuration accuracy. Misconfiguration can lead to network issues. Ensure all settings on both the physical and virtual layers are correctly configured and compatible. Monitoring and management. Regularly monitor the link aggregation for any failures or performance issues and adjust configurations as needed. Ultimately, the decision to use link aggregation on a Hyper-V virtual switch should be guided by your network demands, the criticality of maintaining continuous network service, and the capacity of existing infrastructure. If your current setup without aggregation meets all your needs in terms of performance and reliability, adding link aggregation might not be necessary.
So you see here that he gives you the option to put link aggregation if you need it, okay? Because sometimes it is not necessary. Anyway, so this is how we can do that link aggregation on Hyper-V switch using the PowerShell command. As we can see here also that the teaming is done in the Windows operating system feature, not through the Hyper-V manager. So here I tell him to verify the statement because this was a wrong statement. This was not a good. This is not the correct statement. So I tell him to verify this statement from Gemini, and let's see how he told me. Okay, or let's see the answer of ChatGPT. Let's see what was the answer.
The statement you provided contains a good overview of setting up NIC teaming on a Windows Server 2022 with Hyper-V for improving network redundancy and performance. However, there are some inaccuracies and points of confusion in the process described, particularly around how you access and configure NIC teaming settings. Here's a corrected version of the steps based on typical Windows Server and Hyper-V setups. Corrected steps for NIC teaming on Hyper-V in Windows Server 2022. 1. Open network connections. Instead of using Hyper-V Manager, NIC teaming is configured within the Windows Server operating system environment. You would start by accessing the network connections through the control panel, or by searching for ncpa.cpl in the Start menu. 2. Open NIC teaming interface. You can access the NIC teaming settings by right-clicking on any of the network connections listed and selecting Properties, then click on the Configure button. Go to the Teaming tab. Alternatively, you can open Server Manager, then navigate to Local Server, find NIC teaming, and click on Disabled to change the settings. 3. Create a new team. In the NIC teaming dialog, under the Teams section, click on Tasks and then New Team. Provide a descriptive name for your team, e.g. VM Network Team. 4. Add team members. Check the boxes next to the NXCs you want to include in the team, NIC1 and NIC2. 5. Configure teaming settings. Set the teaming mode, switch independent or switch dependent. Switch independent mode does not require any specific configuration on the switch to work, making it simpler and often the preferred choice for scenarios where switch support is uncertain. Choose a load balancing mode, such as address hash or dynamic. 6. Apply and verify settings. Click OK to create the team. You can then verify the operation of the NIC team using Server Manager by viewing the NIC teaming section and checking the status. Key points. NIC-C teaming configuration access. It's important to note that NIC teaming is configured within the Windows Server settings, not directly inside the Hyper-V Manager. Network resilience and performance. Once the team is set up, all network traffic intended for the Hyper-V host can potentially benefit from the increased resilience and performance offered by NIC teaming. Virtual machines hosted on the server can be connected through the Hyper-V virtual switch that interfaces with the NIC team. Your revised scenario corrects the process and clarifies that the configuration is done through Windows Server interfaces rather than the Hyper-V Manager. This setup will ensure your VMs hosted on the server can achieve the desired outcome of improved network redundancy and potential performance gains.
So as you can see here that there was a problem with the answer of Gemini. It said that the teaming done through the Hyper-V Manager, which is not correct. So this is a regular thing with Gemini. It gives incorrect statements more often than ChatGPT-4, or ChatGPT-4 most accurate one, then Edge Copilot. Okay, Claude sometimes make wrong answer, but not like Gemini. I am actually astonished why this is done through Gemini. They have a lot of data to train their AI model, but still it's giving the wrong answer more often. Even some say that this is not only with the free version of Gemini, but actually with the Pro version, or what we can see here, that Gemini Advanced. Okay, so strangely, how Gemini can compete with the other AI tools, I do not understand. So this is how we can do virtual or do network teaming, network adapter teaming through the virtual environment. The steps involved every hypervisor like vSphere, or the most common ones, the vSphere and the Hyper-V. So let's return to our lab. We have already added the next or the second network adapter, and we need to open the virtual machine and make network teaming between them. So let's go and do that. So as you can see here, also another thing rise to my mind. I try to uh, uh, make or to free more RAM so I can open or work with my virtual machines. And by the way, there is a problem with the Edge, or it's not a problem. There is an option that after closing your Edge, still it is operating in the background. So this takes some RAM. You can free some RAM if you configure the Edge not to work after closing. So this was one of the things uh, that freed some RAM for me so I can operate with my virtual machines. Also, I have asked the AI how I can do that. So you can see here there is a question. I'm asking him, how do I prevent Edge from running after closing it? So here is the way that you can do that. He gives us, or give me, the steps to do that. Let's see the answer. So you can, if you have the same situation, or you need to free some RAM from your PC and you have Edge currently working on it, so you can do this by following these steps.
To prevent Microsoft Edge from running in the background even after you've closed the application, you can adjust the settings directly in Edge or manage background apps in Windows settings. Here are step-by-step instructions for both methods. Method 1. Adjust settings in Microsoft Edge. 1. Open Microsoft Edge. Launch the browser on your computer. 2. Access settings. Click on the three-dot menu icon in the upper right corner of the browser window, then select Settings from the drop-down menu. 3. System and Performance Settings. In the Settings menu, look for System and Performance, or just System, depending on your version of Edge. Click on it to open the system settings. For background apps, look for a setting that says Continue running background apps when Microsoft Edge is closed, or a similar phrase. This setting controls whether Edge can run tasks in the background even after the browser window is closed. 5. Disable the setting. Toggle this setting off to prevent Edge from running in the background. Method 2. Manage background apps in Windows settings. If you want to manage this behavior from the Windows operating system settings, applicable to Windows 10 and Windows 11, here's how. 1. Open Windows Settings. Press the Windows key I to open the Settings app, or search for Settings in the Start menu. 2. Privacy and Security. In Windows Settings, navigate to Privacy and Security in Windows 11 or directly to Privacy in Windows 10. 3. Background Apps. In Windows 10, scroll down to find Background Apps. Click on it, and you'll see a list of apps that can run in the background. In Windows 11, under Privacy and Security, look for Background Apps and click on it. 4. Disable Edge running in background. In the list of apps, look for Microsoft Edge and toggle it off. This will prevent the app from running any processes in the background after it's been closed. Additional tips. Check for malware. If Edge continues to restart or run in the background despite changing these settings, it might be a good idea to scan your system for malware. Sometimes, malware or certain browser extensions can cause unexpected behavior. Task Manager. If you notice Edge still appears in the Task Manager after closing, ensure all instances are closed from there, or investigate any extensions or particular sites that might keep it active. By adjusting these settings, you should effectively stop Microsoft Edge from running after you've closed the browser, helping to save system resources and potentially improve the privacy of your browsing sessions.
So we can see here this is the way to prevent Edge from running in the background. Another way, you can open the task manager, and then in the startup you can disable Edge running in the startup also. This is one of the things. And again, I asked Claude about the same question, how I can prevent Edge from running, and he gave me this answer, the same as ChatGPT 4, but he has added another thing or another option is to prevent, let me see here, to prevent uh, something called boost, startup boost. Okay, he said that startup boost option in the age setting also can help us to prevent running Edge in the background. So for example, let me show you all what I mean by that. So if we go there, okay, let me go to the question. Okay, there is something here called startup boot. If you go there to the setting, there is something called in the system performance startup boot. Get to the browser quickly when it is on. So this helps open Edge faster. So this takes from the system resources. So let's ask ChatGPT, why does prevent startup boost, if applicable, prevent Edge from running after closing it? So he is telling us, let's see here the answer again.
Yes, disabling the Startup Boost feature in Microsoft Edge can influence how the browser behaves after you close it, although its primary function is slightly different. Startup Boost is a feature designed to make Edge start up faster by allowing some core Edge processes to run in the background even when the browser is closed. These background processes use minimal resources but help Edge launch more quickly when you open it. If you're experiencing that Microsoft Edge continues running after you close it, disabling Startup Boost might help reduce this behavior, although the key setting for completely preventing Edge from running in the background is the Continue Running Background Apps When Microsoft Edge is Closed setting. Here's how to disable Startup Boost in Microsoft Edge. How to disable Startup Boost in Microsoft Edge. 1. Open Microsoft Edge. Start your Edge browser. 2. Access Settings. Click on the three-dot menu icon in the upper right corner, then select Settings. 3. System and Performance. Navigate to System and Performance on the left side menu. If your Edge version is slightly different, it might just be labeled as System. 4. Disable Startup Boost. Look for the Startup Boost option. There will be a toggle that you can turn off. Click the toggle to disable Startup Boost. 5. Review Background Apps setting. While you're in this menu, also check if the Continue Running Background Apps when Microsoft Edge is closed option is turned off if your goal is to prevent any Edge processes after closing the browser. Additional consideration: restart Edge. After making these changes, close and reopen Edge to ensure that the new settings take effect. By managing these settings, you can control how Edge behaves regarding startup speed and background processes. If you disable both Startup Boost and the Background Apps option, Microsoft Edge should not run any processes in the background once you close the browser, thereby not affecting your system's resources when not in use.
So this is very good answer. As you can see here, this one of the things that I have noticed during using my Edge or using the Edge browser. So uh, this is one of the things. So this was a note, so we can go and continue our lab again. Okay, so I have done it by a manual way by ending task of the Edge, so I can free some memory. Sorry guys, let's continue now. We will uh, open our virtual machine and begin working. Now we have added the second network adapter. We need to team them and then uh, do a couple of things. We need to rename the PC or to make another PC name, and then open the remote desktop option. So we needed to do a couple of things before uh, making this virtual machine a domain controller. We need to update the operating system, we need to update the antivirus, we need to make or set a specific computer name, we need to give it a static IP address. So all of this should be done in the few moments coming. So now we are logging in with the local administrator account. We need also to organize the desktop. We need to put the control panel on the desktop, this PC icon. All of this, by the way, I have already a login script that will add all of this setting, but I'm just doing it manually, and actually also configuring the time zone to match my country current time. Okay, so I needed to make it Egypt or Cairo Standard Time because it's now on Canada. So now we can open and begin configuring our server or preparing it to be a domain controller. So you need to open the server manager and begin configuring the server. So I can see here it is very slow because actually it is the same hardware requirement like the Windows 11. If you need to work with a Windows 11 operating system, you need to have at least 4 gigabyte of RAM. Remember that I have for this virtual machine 2 gigabyte of RAM. I don't have much RAM to give it or to spare it or not to give it to this virtual machine. So I need to change the computer name. You need to open remote desktop so I can access it remotely, and then to make the neck teaming, change the time to Cairo and the activate this operating system version. Okay, we have a key, and I need to disable Internet Explorer enhanced security configuration. Actually, we don't need or we don't work with Internet Explorer anymore, but this is a good option to disable because if you still have it, every website you access, it will give you a warning to allow this website or to put it in the security or to put it in the allowed websites zone. Okay, so this is a good way to disable it. So as we can see here, we need to enable remote desktop. Okay, first of all, to change the name and give it another name, DC, domain controller, SM, simulation, okay, 01, the first domain controller, 25, this is the version of the server, and we need to restart. By the way, do not make neck teaming and put an IP address during the renaming of the PC. You need to rename the PC, then restart, and then begin the process of teaming, okay? I can see here the RAM is still at high, but I think this is related to my applications installed on this host. Okay, I have a lot of applications, I need to remove some of them anyway. So continue working with the virtual machine. I have made a restart. Let's go further. Still we can see the age running in the background, even though I have already uh, end the task all of the processes anyway. So it's restarting and it hangs as usual, so we need to restart from here. Restart. Now we can continue working. Now we have changed the PC name. Now we need to enable remote desktop option so we can access the server remotely. Then changing the time zone to be Cairo time zone and activate this Windows version using the key. It is provided by Microsoft, so when you are downloading this version, it gives you the key to activate it. Okay, so you need to open the server manager and then begin working with the other configurations for the server, and we need to pass this or to make the start menu to be at the left, not at the center. We have done this before. So we go to the local server. And then we need to open the remote desktop. Okay, then we need to allow remote desktop connection or remote connections to the server, to this computer, allowing from only authenticated levels or network authentication level from users within the network or within the domain, and you can specify the users, and then the rules are added to the firewall to allow the remote desktop. This is a good thing to know. And then another recommendation, not to open to allow remote assistant connection to the computer. This option should be disabled because it will allow anyone to connect to this PC not from within the network. We need network level authentication. Okay, so we need to disable this option. This is a security best practice. Okay, not to enable this option. Okay, you can enable this one with this setting. Okay. Anyway. So now we can go and change the time zone. Here I'm just revising the network to see if I am connecting to the right network. Here, this is the IP address 192.168.79, our server B79.7. So this is the network that we are currently working with, or the range, okay, the network range. So we can now enable NIC teaming. This is how is NIC teaming done from the operating system. So we'll go and get the two physical adapters and to make teaming between them. Maximize the window, okay, and then choose both of them and make NIC teaming. Right click, add to new team, give it a name, and now leave everything. But here you need to change it from dynamic to address hash, because it will not be accepted in the VMware Workstation Pro environment. It will be accepted in the Hyper-V as dynamic, but here it doesn't accept the dynamic loading balancing mode. It accepts the address hash. It will give you an error if you have it as dynamic. So now we need to wait until both are active, and after putting the IP address, we need to make sure this IP address give it access to the internet so we can update the operating system and update the antivirus. You need to install an additional antivirus because the Windows Defender antivirus is not a good antivirus to depend on. So you need to install the antivirus system, then update it, and then update the operating system. Okay, so you can see it is active. Now we can access the internet to see, or before that we need to give it a static IP address. We need to define the default gateway, okay, and give it a static IP address and access the internet. So now we need to make this view to be small icons because this is better so you can see everything. Okay, network sharing, and then this is the NIC teaming, and then properties, and then TCP IP. First we need to disable version 6. Okay, this is an optional step. You can leave it, but it increases or decreases some problems that may arise using IP version 6. Some recommend to disable it. Okay, 192.168.79.7, this is the IP address, the subnet mask, then the default gateway so it can access the internet, then the preferred DNS will be the gateway. Okay, the gateway contains DNS, and alternative DNS will be Google DNS server. Okay, so this is temporary until we update this operating system, and then the preferred DNS will be the IP of the server because this will be a domain controller. Okay, so we can now add the setting and then make sure we access the internet, close, and then begin working. We open the browser to see if we have internet access. So we can close. We can see the speed is, it is aggregated is 2 gigabyte, so you work with double speed because there is two network cards that are teamed. So let's close and try to see if we have internet access. So we'll open the Edge browser and then bypass the welcome messages or the initial setup. Okay, confirm. Okay, confirm and start browsing. Okay, so now we have internet access. Now we need to update the operating system and update the antivirus. Before, in order, first you need to install antivirus, update it, and then update the operating system. You can do both simultaneously. Before that, I think I need to change the time zone maybe. Let's see. First, we need to activate this operating system. We have a key already, which is already listed in the Microsoft website. So we go there and get the key, Windows serial, okay, and this is the key. It's for the data center. We can copy it and activate our Windows operating system. You can go there and tell him to change product key. Okay, and then add the key. Next, activate. This will take some time, and then you have an activated Windows operating system. And this key is only valid for the preview versions, okay? This is not for the final release, okay? So do not use it. It will not be accepted. Okay, so now we can change the time zone to Cairo, okay, just to put everything in order. Okay, so now we can go to Cairo, okay, it's +2 Cairo, and then okay, so now we have every setting done. We have it activated, we have the correct time zone. We need to update the antivirus and then update the operating system, install the updates. This should be done before promoting this server to be a primary domain controller. Need to be very sure that you have the latest updates both on the operating system, for the updates for the operating system and for the antivirus. Okay, so we can go to the virus and threat protection and then go to setting and see if we can update it. So we can go to home, okay, and go to virus and threat protection. Then we can go down for the protection updates. Okay, so you can see here protection updates and check for update. So now it is updated. Now we can go and update the operating system, open the setting and Windows updates, and make sure our operating system is up to date. So this is the Windows update option. Now we can see we have a couple of updates pending. We need to install them and restart the machine. This is the cumulative update. We need to check the updates twice so we can get the latest updates. Okay, so restart now, it will restart. And then it will take some time. We can, okay, updates are on the way. So I think we can pass this real quickly. Here I'm just checking the RAM usage. Okay, still we are on Windows updates. Restarting, finished installing the updates. Restart the machine, and then the last step is to prepare or to change the network setting to put the prepared DNS to be the IP of the server, because this will be a primary domain controller and a DNS server at the same time. So you need to change the setting so to be preparing or prepare the virtual machine to be a domain controller. Okay, so now we can log in, okay, with the local administrator password, which by the way, this account will be disabled and renamed as a best practice when you promote this server to be a domain controller. Okay, and this password should be changed regularly, the same as your domain admin account. Okay, so need to pass this real quick anyway. So Now it will take some time until it, you can see here it's very slow because I am giving it minimal hardware requirement. Okay, I don't have much of RAM to spare or to give. Okay, so we can pause this real quickly. So here I'm trying to shut down the machine. Why? I don't know actually. I think here you can see there is a hang issue. I'll try to start the machine or close it. For some reason it doesn't work. So the only way to do it is to power off. Now I am power it off. Okay, so I think now I will open it back. I think still, or what I will do, I think yes, I'll power it back because it hanged for some reason. Now we can go back and log in again and see what remains here. Okay, here it will ask me if there is a hang issue. Anyway, so what I'm doing here, I tell him to personalize. I need to put the icons or this PC and the control panel to be on the desktop. Here we can see that shutdown event. Okay, it was a hang issue. So we need to open it, or I need to first personalize my desktop to have a couple of icons displayed. Personalize, and then you can go to uh, personalization and then themes to add a couple of icons on the desktop. So you go to themes, you can see here that is regularly the menus are changed and their location is changed from one Windows version to another, which is a real headache and a pain for us users. Okay, even technical users. Okay, it is changed regularly. Microsoft is not giving, or it is not given one menu. It's changing it every now and then. Desktop, so we need to have computer, users, and control panel and network. Okay, and then apply and okay. Actually, I have a script to do that actually, but just to make it more easier for me to handle this server. So now we can go and change the network setting to remove the default gateway, okay, as a preferred DNS, and put our server IP address, because our server will be a domain controller and at the same time it will be a DNS server. So we need to make sure that we have this as 7. Then okay, we can leave the alternative DNS to be for Google until we have an additional domain controller added. Okay, this will be our alternative DNS. Okay, so you can tell him okay, and this will be the end of our video. In the upcoming video we will work on promoting this server to be a domain controller. So now we are shutting down the machine. Take care that when you shut down the machine, it will not shut down normally. You need to power it off. Okay, this happens a couple of times with me. Okay, but for that we need to take a snapshot. Okay, so you need to take a snapshot, so if everything or anything happened, I can uh, revert back. So the snapshot here is my snapshot. It was taken instantly or very fast because I have shut down the machine. Okay, so now I just renaming the snapshot to make it more make sense. Okay, before AD, and then this is the end of our video. Hope this video is informative for you all, and until I see you the next video, thank you and bye bye.